Okay, so this is the hint for number 3. Number 3 are going to be law of sines and law of cosine problems. This one is actually going to be law of sines. So before we get started, let's go ahead and label our triangles. Let's just say that this is A, this is B, and this is C. And honestly, you have freedom to label A, B, and C. What has to be true is once you decide what big A is, that automatically makes the opposite side little a. Whatever you decide big B is, that automatically makes the opposite side little b. And then whatever you decide big C is, that automatically makes the opposite side little c. So you can do A, B, C in any order. It's just once you pick that order, the lowercase values have to go in certain positions. So let's just go ahead and write out the law of sines. We know that sine A over little a equals sine B over little b, or sine little b over little b equals sine big C over little c, or lastly sine big C over little c equals sine big A over little a, right? So those are 3 different versions. In this particular case, we need to think about what evidence we have and what evidence we want. We want this angle, so that's got big A. So let's go ahead and get rid of this version. We're not going to use this version because there's no big A, and that's what we're looking for. The problem with using this version will be, hey look, we don't know big C, we don't know little c, so we don't have a lot of information to use, so we can get rid of this version. So let's use this version of the law of sines because A is what we want to find, and B represents what we know. So the best equation always takes what you know and what you want and writes them in one equation. So let's rewrite out sine A over A sine B over B using the values in our picture. We don't know A, so we can just call it sine big A. Or you could also call it sine X, that would be fine. We do know little a is 35, so divided by 35 equals sine big B means the sine of 100, and little b is 50. So we want to solve for big A. So let's get rid of divide by 35 by multiplying by 35. So now we have sine A equals, and there's a few ways you can write this out, but let's just say it's 35 sine 100 over 50. Because remember, the order you multiply doesn't matter, so you can always multiply 35 first, and when you multiply a fraction, you multiply the numerator. So this was sine big A, sorry. And then look, our goal is to solve for A, so we have to get rid of sine. To get rid of something mathematically, you have to do the opposite. The opposite of sine is what's called sine inverse. I don't know if you remember that from this unit, but right, to get rid of sine or to get rid of cosine, we use the inverse button or the inverse operation. So we're doing sine inverse this whole thing. And I should point out, look, I haven't simplified anything. We haven't done sine 100. We haven't divided by 50. And the reason is, if you save all the calculations for the very last step, you get an answer with your calculator that's as accurate as possible. So let's go ahead and go over to the calculator and type all that in. I hope I remember what it said. I think we have, we're going to be doing sine inverse on the outside. So sine inverse of, and in the numerator I think we had 35 sine 100. And then I want to close those parentheses. And in the denominator, we had 100. And let me just double check. This parentheses and this parentheses match up. That parentheses and that. All right, so that should be good. And so we have a side of about, an angle of about 20.162. So let's flip over and fill that in. So this is about 20.162. Okay. So this was a law of sines problem. What made it law of sines was that we knew a lot about b, big B and little b. So we knew this, and we were looking for this. Let's look at the next one. I left it off in this picture, but I think the unknown side we're looking for is down here, so we'll label that x. So let's go ahead and label our triangle, and like I said, we can label it any way we want. So let's call this C, let's call this A, let's call this B. It really doesn't matter. What does matter is now that this is big C, 12 has to be little c. Now that this is big B, 13 has to be little b. And now that this is big A, when we're looking for x, that's really the same as looking for little a. So we have our choices for the law of sines, right? We've got sine big A over A equals sine B over B. We've got sine B over B equals sine C over little c. And then lastly, sine big C over little c equals sine big B over little b. So I want you to pause the video in a second and think which version is appropriate for finding this side. Unpause the video. Oh wait, I guess maybe you can't hear that if you pause the video. Anyhow, let's see. Let's look at A. Hey, A has what we're looking for. We know big A. We know little b. But you know, we don't know what big B is. So this version is no good. Let's look at number 2. We're looking for little a, and it's nowhere present at number 2. No good. Oh, I'm so sorry. Number 3 is wrong. It should have been sine. The only combination we had left was sine big A over little a. But look, number 3 has what we're looking for. We know big A. We know little c. But we also don't know big C, so we don't know this value, so this is going to make this one not work either. So what this really is a law of cosines problem. And this is going to be the one that starts out a squared equals b squared plus c squared minus 2bc cosine big A. The reason it's a good law of cosines problem is A, law of sines isn't going to work, but B, let's look. This is what we're looking for, so that's good. Do we know little b? Yes. Do we know little c? Yes. Do we know little b and little c? Yes, we've already said that. And do we know big A? Yes. So this has got all the ingredients that we want. Let's go ahead and substitute them in. We don't know a, and that's fine. We'll just call it a squared. We know that little b is 13, so 13 squared. We know that little c is 12, so 12 squared. Minus 2 times 13 times 12 minus, cosine, and then big A is 30 degrees. And I think we can go ahead and type this all in as one row in our calculator, and then we'll just square root it as the last step. So let's flip over and do that. I believe it was 13 squared plus 12 squared minus 2 times 13 times 12 times the cosine of 30 degrees. And so that's the total, and we still need to square root that. So we're going to do second square root, where is it? There it is. And then we could retype this and square root 42.8000 whatever, but I'm just going to use that answer button, which basically means, dear calculator, type in my last answer for me. And we get 6.54. All right. So what we get here is A equals 6.54. I'm going to go ahead and pause the video or stop the video and make the last part of hint number 3 a different video. So look for hint number 3 part 2 to finish up this example.